Okay, so hi everyone, good afternoon. I'm very happy to introduce our second keynote speaker, Eeckhout. Ian is professor of economics at the Pompeu Fabra in Barcelona, which is also where he started his career about 2 decades ago. Ian has been a tenured professor at the University of Pennsylvania at UCL, and has been also a visiting professor at the Princeton, NIU, and MIT. His work is broad in terms of topics and ranges from theoretical and applied work. He's a prolific researcher and has made a lot of important contributions to several areas. I'm going to briefly focus here on two, labor market and market power. Jan is one of the leading scholars in the field of matching and has made numerous contributions, actually too many to list them here, analyzing the sort of heterogeneous agents and its implications in several empirical relevant environments, and also studying the identification of sorting the data. More recently, Jan embraced a new topic of market power and has documented a remarkable increase in economy-wide markups over time, both in US and globally. His finds on large increase of market power has triggered a heated debate about whether the influence of monopoly power has grown beyond its traditional microeconomic realm of a single industry or market and into the economy overall. If average levels of market power have indeed grown across the board, this is likely to degrade key metrics of economy-wide well-being, including investment, innovation, total output, and distribution of income. And we will probably hear more about this today, so without further ado, I would like to welcome Jan Eeckhout, our second panel speaker. Jan, thanks very much. The floor is yours.
Thank you, Marcelo. Thank you very much for this very kind introduction. It's a great pleasure to give this plenary talk here in Brazil. I would like to say it's with great sadness that I could not be locally present, but hopefully sometime soon. Thank you very much for the great organization of this conference. Given the circumstances, it's amazing how wonderful this is going. So what I would like to talk about today is about, as Marcelo was hinting at, market power and the labor market. And in particular, I would like to think a little bit about whether market power could have any contribution to wage inequality. This is joint work with Shubdeep Deb, who's at UPF as well, Asim Patel, who's both at the UPF and Sciences Po, and Larry Warren, who's at the Census. And there's the usual disclaimer that I have to say here, that none of these opinions here are the opinions of the Census Bureau. So what is our kind of motivation? The motivation is that we've seen a rise in inequality since the 1980s. On the slide here, you can see basically a picture of what we call the skill premium, which is the ratio of the average wage of these workers with a college degree or more versus the or related to the average wage of those with a high school or less degree. And what we see is that while there was kind of some inverted U-shaped pattern from the 60s to the 80s, since 1980 we've seen a steady rise. And basically from 1980 it was around 50% this premium, so you were earning on average 50% more if you had a college degree or more. And by the late 2010s, you had around 90-something, nearly 100% more. So basically, the skill premium had this sharp rise from plus 50% to plus 100%. So now, this is well documented. This is something that people have studied extensively. And I would like to revisit the same question from the point of view of, well, is there any relationship with market power? And now let me just kind of give you a correlation, and then I want to dig deeper into our understanding of it. And the correlation is the following. Let me put on the same graph, but of course with a very different axis here, the pattern of markups. Okay, and this is from the work with Jan de Lukker and Gabriel Unger. And what is this markup pattern here? What we measure is basically the price to the marginal cost, which is typically how in IO people define what a markup is. It's basically, taking away fixed costs or taking away any type of overhead cost. It's basically the margin that firms make on the production of goods. So you can think of any variable costs that contribute to the production of a good. What is the price at which you sell relative to the cost? And now we see a fairly similar pattern, initially inverted U shape up to the 1980s, and then a fairly steady rise from 1980 onwards. And what is the interpretation of this? Well, let's now look at the right-hand side scale. The markup in 1980 was around 20%. Okay, that means that prices of goods were about 20% higher than the variable cost of production, and that went up to about 1.6 or 60% above the cost of production. And so we see that over that same period that there's a sharp rise in the skill premium. We see also a sharp rise in these markups, in these measures of market power. By the way, if you were to look at profits, that takes into account fixed cost, you will see a very similar pattern of a rise in markups. I should say here that, while I'll show you averages here, both for the skill premium and for the markups, what we see is that there's underlying also a lot of heterogeneity, and in particular with respect to markups, it is not the case that the markup has gone up for all firms. It's not the case that we see a rise for all firms from 1.2 to 1.6 in terms of the markup. In fact, one of the things that we observe is that the heterogeneity, the distribution of markups has become much more dispersed. Okay, so basically the 90th percentile, for example, in 1980 was around, from memory, 1.5, and it went to nearly 3. Okay, so you see basically a fanning out of that distribution, telling us that it's not just the average that's going up, it's basically the upper tail that's going up. And in fact, the median markup is fairly constant. Most firms see no increase in their markups. And this is going to be important for the motivation why we believe that there could be a relationship between market power or markups as we measure them and the skill premium, i.e. the inequality in wages. By the way, I should say that I'm happy to be interrupted at any time, so you can either raise your hand or post a question or relay them in any other way. So I'll be happy to take any questions throughout. Okay, now in terms of the interpretation, the consensus in the literature is that the rise of market power is to a large extent due to the fact that there is a change in technology. Okay, and so people have talked about skill-biased technological change that I'm going to come to in a second. But what I would like to ask is, okay, sure, given this strong technological change, is there also any role for market power given this coincidence? Okay, and what is the contribution of market power to this rise in the skill premium? Now, why does market power matter? Ultimately, if you say, okay, we understand that, well, technological change causes, for example, the market structure to change, then eventually or originally everything is driven by technological change. And in a sense, that could be one interpretation. But it is still important that, first of all, we simply understand the mechanism, that technological change separately driving markups, but at the same time, a skill premium, but at the same time, that market power or the market structure also drives the skill premium from a different separate angle. To understand this mechanism is important. And this is going to be important not just for our understanding, but also for policy. Why? Because if it's pure technological change that drives the increase in the skill premium, then basically what we're saying is that the high skilled workers are more productive and they're basically being paid according to what their marginal product is. And so that's efficient. So there's only a role potentially for redistributive policy based on the second welfare theorem, for example, but there is no role to improve efficiency. I mean, we have efficiency due to the fact that we have pure technological change that is the only driver of the rise of the skill premium. Instead, if market power drives the rise of the skill premium, then basically intervention is going to be efficiency improving, because we know that the market power equilibrium is going to lead to basically a second best allocation. And then the first welfare theorem is going to, or there's reason for intervention on the basis of the first welfare theory. Okay, and then the question is, how do we intervene in the product market, or do we want to intervene in the labor market? And I'm going to try and hint at some answers that we can give to them. Now, what I'm going to do today is I'm going to basically propose a way to think about the large economy. Okay, and in this large economy, we're going to think about a technology that's firm specific, that is driving the productivity of high skilled and low skilled workers. So the first thing is that I'm going to have on the one hand a technology that's going to be heterogeneous, and we're not going to look at a representative firm. And the reason behind this is what I mentioned at the introduction, or early on in the introduction, that I was saying, well, if you think about technology, okay, and technological change, heterogeneity plays an important role also as how it affects market structure. And so basically I want to look at the heterogeneity in this technology that we're going to estimate. We're going to estimate a distribution of productivities, okay, that is going to be specific to each firm, and it's going to be specific to each skill. The second thing is that we're going to be able to distinguish between what is heterogeneity within the firm, driven basically or giving rise to what the skill premium is, the relative productivity within and within the firm between high skilled and low skilled workers, and between firm inequality. And we know that in the last few years, people have discovered, including for Brazilian data, but for a whole series of countries, the US, Germany, the Scandinavian countries, that we've seen that the rise in inequalities is predominantly driven by an increase in between firm inequality, more so than an increase in within firm inequality. Okay? And we expect to see that in the estimated productivities, because we expect to see that basically there's going to be more heterogeneity between firms. Now, if on top of this firm-specific and skill-specific technology, we also are going to allow for market power, basically then we're going to be able to allow for the fact that market structure matters and is basically a driver of the equilibrium outcomes, and in this case in particular the skill premium. Okay. Now what we're going to do is we're going to look at market power in both the goods market and the labor market. Okay, so we can think of it as in the goods market where firms set prices higher than their marginal cost, okay, in a way that allows them to have positive profits and basically extract rents from the customers. But we're also going to have labor market power, which is a way of thinking of monopsony or oligopsony in the case of multiple firms competing, and that basically leads to an equilibrium rent sharing. It's kind of the flip side of goods market power, in the sense that the firm in the goods market basically is one of few competitors to sell a particular good. In the case of monopsony power, the firm is one of the few competitors demanding labor. Okay? And so basically it's on their labor demand side that there's basically too few firms competing. And what that means is that there's basically going to be an upward sloping labor supply curve as a result. Okay? What that means is that basically we're going to have upward sloping labor supply, in the sense that as the labor that's being supplied is increasing, the wages are going to be increasing. What we're going to do is, once we assume this market power both in the goods market and the labor market, we're going to estimate what the market structure is. And the reason why we want to estimate it is because when we were to, if we alternatively we were to use an index of concentrations such as HHI, the problem with that is that over long periods of time and across very heterogeneous sectors, what we observe are really very extreme differences in the evolution of HHI that are driven by, for example, changes in population. Okay, the way you want to think of HHI, for example, changing with population, is that if I look at the definition of a market, for example, cities or metropolitan areas, for a particular type of good, let's say coffee stores in Sao Paulo, what happens is that at these coffee shops, as the population becomes denser, we tend to see that there's more coffee shops opening up in the same area. Now, that doesn't mean that the coffee shop market is now more competitive. It's just that it's a denser market. Okay, and we see evidence in the data that HHI indices for over long periods of time see certain trends that are just driven by population, for example. So we don't want to use HHI because we don't have a very good idea of how to measure market, and we're going to estimate this. So what are the main insights that we find? First of all, regarding firm heterogeneity, what we see is that there's a rise in the heterogeneity of productivity, and this can kind of account for this dichotomy in the within versus the between inequality rise. Okay, and this kind of heterogeneity of productivity, this increased kind of heterogeneity is a sign that there's more between firm inequality. Second, regarding the market structure, the estimated market structure that we find is that indeed there's a rise of market power in both the goods and the labor market. The market power increases the skill premium, quantitatively accounts for a sizable part. I'll show you when we get to the quantitative exercise. And in fact, possibly the biggest effect is that the wage that is being paid to the households who provide labor is going to decline even without having technological regress. What do I mean by that? Well, take the standard competitive argument for the increase in the skill premium, which I'm going to lay out in the next few slides, but let me just give you a kind of a preview of that. The idea there is based on the fact that if you're a high-skilled worker, you become more skilled relative to a low-skilled worker. Now, if everyone becomes more skilled, it's just that the high-skilled, become more skilled at a faster rate than the low-skilled, then basically the wages for everyone should go up. And you can imagine that technological progress, okay, over the last 30, 40 years has implied that, the high skilled have become more productive, but the low skilled too, maybe not as much as the high skilled, but they also have new technologies, there is an increase in the productivity also for the low skilled. So we would expect to see a rise in the wages. Now, the opposite is true. For the lowest skilled wages, we see actually wages either stagnating or declining in real terms. Now, in a competitive world, that's only possible through technological regress. That's only possible if the technology has become worse over time than it was, say, 40 years ago. And that's hard to imagine, because why would you think that, the technology that we had 40 years ago is not available today? I mean, if you could be as productive 40 years ago, why would you be less productive today? And this already hints at the fact that technological regress is not the explanation for this decline in wages, but it's driven by market power. And we see that market power has a huge effect on the wage level. Even if your productivity doesn't go down, or even if it goes up, the rise in market power kind of outweighs the effect on wages and basically depresses, lowers wages. And so all of this is going to allow us to address the issue of what the welfare cost of inequality. If there's no questions at this point, what I would like to do is I would like to first give us a brief overview of the standard framework in which we think about this type of skill premium, which is the Katz-Murphy model or interpretation of what the skill premium is. And I'm going to follow exactly that with only a minor set of modifications. So Katz-Murphy has a representative firm that has a production function that takes as inputs low-skilled labor and high-skilled labor. And the quantity of output that's being produced depends on a technology parameter that says how productive low-skilled labor is, and the technology parameter for the high skill that says how productive high skilled labor is. And so, because the firm is representative, whatever happens at the firm level happens at the aggregate, because this is, by the way, also constantly recurs to scale. So this CES technology, basically, what you see at the firm level can be interpreted as an aggregate output. The missing piece here is the elasticity of substitution sigma, that basically tells us how elastic the inputs of labor, low-skilled and high-skilled labor are. Now, if you look at this problem and you look at the firm's solution to its profit maximization decision, it says how many low-skilled workers will I hire, how many high-skilled workers will I hire. So I'm going to have two first-order conditions that are written down here. But it doesn't matter what those are. Let me just look at the ratio of these two first-order conditions. And the first thing you'll see is that there's a bunch of common terms that cancel out, okay, that are going to be here. And so, sorry, that these are canceling out, and the only terms that are left over are going to be these, and this is what's written here. And typically people look at this in log terms. So basically what you have is that the log wage ratio can be written as basically a weighted sum of the log ratio of technologies and the log ratio of high to low skilled workers. And the weights depend on the elasticity of substitution. So this expression now is basically the main driver of the explanation of Katz-Murphy, and it can be no more transparent than this because it's actually really transparent. What happens, this is data, we see wages of high skilled and low skilled workers. This is data, we see how many high skilled labor workers, high skilled workers are in the economy, how many low skilled workers are in the economy. For example, over the period from the 1980s to now, this has gone from about 20% of the workforce, and this was 80%, to about 40%. And this is 60% now. Okay, so this ratio has gone up substantially. Now, what you see here is that the rise in this ratio, by the way, let me just, before I finish that, so this is data, this is data. I'm going to make an assumption and come back to that on a follow-up, Asimov and author, what the elasticity of substitution is. Then basically the only unknown is this part. And this is basically what we will be able in Katz-Murphy to back out. So what do we see? We see that the H over L ratio, as I said, has gone up. Okay, this was 0.2 over 0.8, and now it is 0.4 over 0.6. So there's an increase substantially. This is with a negative sign. So what we know from that is that, of course, if the relative supply of high-skilled workers goes up, their wage must go down if everything else is the same, right? So you become more, there's a higher supply of high-skilled workers. Basically, that means that in equilibrium, their wage must go down. But we see the opposite. We see that the wage of the high-skilled is going up substantially, as I showed in the first slide. So the only explanation could be, well, there's a change in the elasticities, as Mowgli and author argue that there is none. So it must come all from the change in the productivity of the high-skilled workers relative to the productivity of the low-skilled workers. Okay, so there's basically what people have come to call in this supply and demand framework of Katz-Murphy skill-biased technological change. The high-skilled workers have become more productive, much more so than the productivity rise of the low-skilled workers. Now, there's alternative aspects to it. For example, the paper of Asimov and author that I was referring to looks at this in a context of polarization. People have talked about, where does this increase in this ratio of high-skilled to low-skilled workers come from in their productivity? Well, there's a paper by Cressell and co-authors that looks at the capital skill intensity of the high-skilled workers. So think of these people using computers. The price of these capital goods has dropped substantially in the last decades. What that means is that their investment in these now cheaper capital goods has gone up a lot, and that's why these people have become more productive. Okay, for the low-skilled worker, this capital skill complementarity is much weaker, and as a result, the drop in the price of these technologies does not have the same effect for them. These are all variations on, if you want, the same explanation. Now, what I would like to do is I would like to show you a model, and in this model, I want there to be basically heterogeneity in the production of firms. So if I just go back to this type of setting, I want there to be one of these equations for each firm. Why? Because as we've discovered in the data, there's a lot of heterogeneity across firms in terms of the markups and therefore the market power that they have. The reason why market power has gone up is not because all firms' market power has gone up, it's because within each market, a few firms are doing a lot better than other firms. So I want to set up an environment in which there's heterogeneity in the productivity of the firms. Let me start, first of all, by saying I'm going to look at a static economy, and I'm going to compare, if you want, an economy from the 80s with an economy from today. So my objective is not to explain dynamics. My objective is not to explain transition paths, which I think is very important, but you will see that there's reasons why we do it, because we basically cannot solve the dynamic problem. The type space explodes if you have this type of heterogeneity that we assume. On the consumer side, we have a representative household, and they're going to basically be active producing in markets that are going to consist of, well, basically there's going to be differentiation of goods. So not all goods are going to be the same. And the way you want to think of this is that there's going to be a particular market that produces a number of goods, I. So think of this as very close substitutes like soft drinks. I have Coke and Pepsi. And then I have a different, so these are two goods, I. Then I have firms that produce those. They may own multiple of these goods. So, Procter & Gamble owns Head & Shoulders and Pampers, so they own different of these goods. And then across markets, we have basically kind of differentiation that's much less close. So for example, if I take the example of soft drinks, I have soft drinks that are competing in a small market with and firms, and then I go to cars, and I had Pepsi and Coke, and then in the cars market I have Toyota and BMW competing, and these different markets are much further from each other in terms of degree of substitution. They're much more complementary. So the way you want to think of this is that there's a large number, in fact, a continuum of these markets, and within the market there's a small number of firms competing. And this small number of firms is going to capture basically the extent to which there is market power. The fewer the number of firms N, okay, the more market power there's going to be. They're going to, for no compete, we can also do per try competition. Okay, both are possible. Now, so I see a question from Braz. Braz asks whether the assumption that the elasticity of substitution between L and H work seems critical. I mean, so basically, let me just, I think this is going back to the Katz-Murphy setup. It's indeed the case that the elasticity here is crucial when you measure it. There's kind of an identification issue how we can measure the elasticity. There's kind of a growing literature addressing this. What Asamoah and author do is they estimate this over, you can do this for every year. You have this equation holds in at least in a static economy, holds in every year. And so basically you can estimate the ratio of technologies that you obtain in for the representative firm, given that you have data on wage and data on the ratio of high to low skill employment. Now, what they do is they basically use the intertemporal variation to estimate this elasticity. I'm going to show you that we can, in our model, vary the elasticity. For the purposes of what we're doing, it has kind of a very small, I'm going to show you that comparative static result. The elasticity has nearly no effect whatsoever on the wage ratio that I'm going to show as we estimate. So if I look at the firm's problem, I basically have a representative household that chooses consumption, okay, across all these different markets, but I'm also going to have these households providing labor in all of these markets. So you can think of this as, a household lives in a particular metropolitan area, Sao Paulo. It works in the coffee industry. Okay, some of its members, but other members work in the car industry, and some other members work in the furniture industry. So they provide labor. It's a representative household to all subsets of the economy. What this is going to do is, or these markets, what this is going to do is, it's going to allow us to model at the same time the market power in the goods market as well as the monopsony power in the labor market. And you can think of this as follows: that in the goods market, I have this index of consumption. See, this is probably the ugliest slide you're going to see today, but I just want to have it up here just to refer to some of the notation. The theta is the elasticity between, say, soft drinks and cars. Okay, and this is going to be a theta that's going to be close to 1. Why? Because these are not very close substitutes. But at the same time, in each market, and notice there's a continuum of those. So I take the integral across all these different markets, J. Now, in a given markets J, what is my index of consumption? It's some aggregation of the individual level of consumption between different close substitutes. So this is my consumption for Coke and Pepsi, okay? And that has an elasticity of substitution eta that's much larger, meaning that there are more that are closer substitutes. So my eta is going to be larger than the theta. So what it means is I can now talk about the different types of goods, but at the same time, I can also talk about here the number of goods that are competing. So basically, there's the elasticity of substitution is determined by how many firms are in this. Sorry, the elasticity of substitution is constant, but the index that I obtain is determined by the number of firms that are competing. And we will see when we come to the production side, the firm's optimization decision, that this is going to affect the number of inputs that they're going to be producing. So now that is what the consumption goods market looks like. What happens on the input side, on the production, on the supply of labor? Well, first of all, the labor that's being supplied is by low-skilled and by high-skilled workers. So I'm going to have one for each of the types. And I'm going to have a similar aggregate labor index that's going to be the aggregation of what happens in each of these markets. Now, the key assumption that we maintain here is that if you have a market for coffee and you have a market for cars and you have a market for soft drinks, that these are all diversified or separate in terms of their consumption value, but also in terms of their production value. If you're a barista in a coffee shop, it's easy as a close substitute for you to work in a different as a barista in a different coffee shop in your same town. Okay, but it's much less substitutable to work as, say, a car mechanic. And so basically the different markets are going to have less substitutability between markets, and here the eta hat L is the elasticity of substitution within the market. As before, the theta and the eta are such that the theta is much smaller than the eta, so these are no close substitutes, these are very close substitutes. Okay. And this also as much for the low as for the high type labor input. So you want to think of this as being a setting where the individuals who work are basically easily substitutable in markets where the goods are very similar. The inputs of labor are not substitutable when the markets are very different. Okay, and that's basically the whole setup. The household rather, chooses consumption and labor inputs high and low. What is their constraint? Their constraint is that the total consumption value must be equal to what their income is, and we're going to redistribute the profits equally to all households. Okay, given it's a representative household, whatever profits are made, the representative household receives that share of the profits. Now let's take a look at the technology. The technology says, it's exactly the same as in Katz-Murphy. The only difference is that now this technology is specific on the type of good that I produce, Coke, the firm that I'm in, and the sector that I'm in, soft drinks. Okay. Now, what that means is that I'm going to have, for each firm, I'm going to allow for a productivity for the low skill types that's different for each firm. And there's a productivity for the high skill type that's going to be different for each firm. So there's going to be a distribution of these. Okay. Now, if I have a distribution of these, my optimal decision, how many of the low skilled workers to hire, and my optimal decision, how many of the high skilled workers to hire, is basically going to be a function of these firm specific productivities. Okay, I'm going to take, these productivities as given as a firm, and then I make my optimal decision how many workers to hire. And that's a problem that we're going to try and solve for. So there's going to be the primitive, if you want, exogenously given is the joint distribution of these productivities. Of course, we can now start ask questions beyond that and say, where do these productivities come from? Maybe firms invest in new technologies, and I think this is an interesting and exciting question that I at this point I'm going to put aside and take this as given. Okay, I'm going to just say, there's a distribution of these productivities, basically just as the way that Katz-Murphy do it. The only thing is that there's really a non-degenerate distribution of those. Now, what is the market structure? The market structure is such that in each firm there's n firms, so in each market there's n firms, and they do no compete. Okay, so what it means is basically they choose quantities, taking into account that the other firms, Okay, know what you're going to do in equilibrium. So basically, everyone plays best response, and we look for the Cournot-Nash equilibrium in this setting. By the way, there's complete information, so everyone observes in the setup of my model what these productivities are for each of the other firms. Notice that the results are going to be similar when we have per-triangle competition, in the sense that we have differentiated goods. So what happens if firms set prices? The exact result is not the same. If you're familiar with these models, and I'm going to show you the solution to in a second, the first order condition basically differs on one aspect. What is the residual demand elasticity? But in all other aspects, it's identical. I think there's a question. Saying you're abstracting from differences across industries and occupations in terms of labor supply. I guess this can potentially exacerbate inequality effects when certain firms become more productive, right? Okay, so I think it's an excellent point. So, there's, when we go to the data, there's different sources of heterogeneity in addition to the one that I'm showing you here. Let's start by the fact, okay, good, we have heterogeneity here in terms of the productivity, AL and AH, but there might be things that are specific to a sector. By the way, if all of the sectors have a higher AL and a higher AH, that's perfectly allowed. Okay, we do not, when we're going to go to the data, necessarily restrict this to be, the same distribution within a given sector. So that you could have, say, a steel sector that's extremely highly productive in capital, but not in labor. So this would affect this AL and AH versus, say, a cleaning service that's going to have to be very highly productive in the ALs, all of them, and not in the AHs, for example. So we allow for there to be differences in the productivities across sectors. Now you might say, well, there's other things that in the sector we should take into account. For example, there are things that are not driven by the relative labor supply. For example, bigger cities, sectors, by the way, a sector for us data-wise is going to be an industry code, an Eeckhout code, crossed with a geographical area. You might have certain geographical areas that have higher wages just because they're more densely populated, for example. Okay, the bigger cities have higher wages. Per se, this could come from the productivity, but you might worry, well, this productivity doesn't exactly measure, for example, the cost of living. Okay? And so what we do, we condition on, for example, geographical observables. Okay? In the sense that we have fixed effects for geography to account for other reasons than these differences across high and low skilled workers. So let's take a look at the solution for this problem. I'm not sure whether I have finished. Yes, I have finished with this. So when we solve the household optimality problem, let me not go into great detail because it's actually fairly standard, but we can write the individual firm's consumption, labor demand for the low-skilled worker, labor demand for the high-skilled worker, or the equilibrium quantities of those. We can write these explicitly. That's the advantage of this CS type setup. And the only thing I want to show here is, without entering into the detail, we can write these kind of price aggregators. I have a price of the aggregate good, I have a price of the sector-specific aggregate good, and the same thing for the wages. These can all be expressed in terms of these CES aggregators. That is, why we have assumed this very simple functional forms that we know well and that people have used throughout. So we're going to have no innovations in terms of the household optimality. Now let's take a look at the producer optimality. What is the equilibrium solution for a firm? So you can write the firm's profit maximization problem as a choice of the high and low type number of workers, given a price for the output goods. So your quantity that you produce is going to affect the price, given that you have market power, because there's no competition. The quantity you produce, and this is basically the cost of the high skilled worker, the wage bill for the high skilled workers, the wage bill for the low skilled workers. Notice that we are not assuming price taking, so these are functions themselves. This WH and this WL, remember, are upward sloping functions of H and L respectively. Now, here's kind of a bit of a lengthy first order condition that I want to show you just to give you an idea of what the problem looks like here. Well, the first part is, this is, by the way, the first order condition with respect to age. I'm going to do exactly the same for the first order condition with respect to L. You can see already that, you know, as you choose your quantity of or the number of high-skilled workers, this is going to have an effect on the output, okay? But it's also going to have an effect on the price, and in the sense that this is the typical kind of residual demand elasticity. This is the Lerner index, if you want, that tells us, you know, what is the optimal choice of the quantity of production and how this is going to affect your output price. And in terms of the cost, we have the same thing here. If this was a competitive market, this would be just WH. But because the market is monopsonistic, as you change the number of workers that you hire, this is going to affect basically the wage that you have to pay. By the way, there's multiple terms here because remember, firms might own more than one subsidiary, okay, in which they compete, and this is how we're going to measure the rise in market power. Now, what's the next equation here? It's exactly the same one as before. It's just I've written this lengthy term as 1 plus the price elasticity, and here I've written this lengthy term as 1 plus the elasticity of the labor supply function. Okay. So these are the kind of the simplified expressions, and then I've rewritten this using the CDS formulation, what our production function, what the marginal product with respect to age looks like. Okay. Now, what's in red here, okay, is going to survive once I also do this, once I write this in terms of the low type input. So what is in black is going to be common terms and they're going to cancel out. Okay, let me come to that in a second. Before I do so, let me first tell you a little bit what that means in terms of this price elasticity and the labor supply elasticity. Well, the price elasticity of the output good can be basically written as, well, the markup is a direct relationship between the price elasticity. Why is that? Because the price elasticity tells us the steeper the price elasticity is, the more market power you have. Okay, so think of your standard monopoly problem. You have the labor demand out there. The firm basically, you know, given that it has market power, uses its residual price elasticities to equate marginal benefit here equal to marginal cost. And so the steeper that residual demand elasticity is, basically the higher the market is going to be. Now, what is this elasticity in the case of this Cournot market? Well, in the case of this Cournot market, what matters is, this is in the output market. I'm going to come to the input markets in a second. In the case of the output good, what happens here is that if I'm a firm that dominates the entire market, say Coca-Cola has 99% of the market, then its residual price elasticity is only determined by the elasticity between markets. The only thing it looks at is cars, furniture, and coffee. It doesn't care about the competitors within its market because it's so large that its share is, say, 99%. It doesn't really matter what elasticity is here. This is going to be close to zero. Okay, so your residual demand price elasticity is just equal to theta, 1 over theta times 1 to the minus 1. Instead, if you're a small firm, you don't really care about what's going on in other markets. The only thing you care about is within your own market. If this is, you know, close to zero, you're a small firm, then basically 1 over theta is the only thing that enters into this residual price elasticity, and this is zero. Okay, so basically a firm that is small is going to have an elasticity that's basically driven by the substitutable good, and that means it's very competitive. And you can see already that the size of the firm is going to matter here. The large firm is going to be more monopolistic, or is going to have more market power. The small firm is going to have less market power. And that's also going to be the case in the input markets, where we can look at the E here is the share of employment of the highest types within your narrowly defined market. If you're a large firm, the only thing that matters is how easy your workers can go from, you're in, say, the coffee business, go from your coffee business to car manufacturing. That's a much lower elasticity of substitution than the one if you're in a market where you compete with other coffee shops, because your baristas can move around very easily. Okay, and so again, how dominant you are determines how elastic your labor supply is going to be, versus if you're not dominant, your labor supply is going to be close to flat. That's true for the high skilled labor input as well as for the low skilled labor input. And by the way, we can define something similar to the markup, which is the markdown, which is again the wedge between the marginal product of the worker and the wage that they receive, which is given by this. So let me just address one more question here from Raz. The relationship between theta and eta will be assumed constant over time, or can you estimate them in different periods of time? That's a great question, Raz. So what we're going to do is we're going to focus on definitely estimating these. At the moment, I'm going to take these from the literature. I'm going to assume them constant, because as you'll see from when I get to the expressions of the skill premium, these are going to matter. But you'll see also why I'm going to focus on this on the next slide. And the short answer is kind of partially, we're going to estimate these. Okay, we're going to take these from the literature. The objective is eventually also to estimate these, but we'll, where we stand at the moment is where we're estimating these. And indeed, they are crucial. Why is that? Well, if I take my my similar problem that I had before, in fact, let me just go back to this slide here. Take a look at this expression here with whatever's in red is going to stay, whatever's in black is going to be common for the low type, so that's going to cancel out. So you're going to have here AL, L, and WL, and epsilon L. Okay, let's take a look at that ratio. Okay, and this is basically written here, the ratio of wages. Well, it had 1 plus epsilon H here, it had 1 plus epsilon L here, so I've just brought it to the other side, and I have AH over L with this term of the elasticity of substitution. I have H over L again with this term of the elasticity of substitution. So let me again write it in terms of logs, and I have the log wage ratio is now what? Well, let's look at what we had before in the case of Katz and Murphy. We had exactly the same thing here, except where this was an aggregate, because there was only one representative firm. Now, this is firm specific, this ratio. I could have a cleaning firm where this is close to 0 and this is very high. So the cleaning firm is very productive with low skilled workers, not productive with high skilled workers. Or this could be a coding firm where this is high for the high skilled workers and this is low for the low skilled workers. Or I could have firms that are productive in both. Okay, so as I said, this is not going to be firm specific. This is, if you want the equilibrium solution, if you were to know this, this is something we're going to see in the data. The wages are something we're going to see in the data. So what are we going to do? Well, we're going to estimate this, okay, in order to derive this. This is basically the kind of summarizing what the name of the game is here. Data here, by the way, I still continue with Acemoglu author elasticities. This is data, this is data. We're going to estimate this from the wage equation using our model, and then basically we're going to back out these. And this is what I'm going to do in the next few slides, trying to convince you that we can do this. Notice that this holds at the firm level. We can, of course, aggregate this up. This is not something that you typically see in the data, or the first slide that I showed you. The first slide I showed you was an aggregate. This was an average wage ratio, right? And we should also take into account that there's going to be general equilibrium price and wage effects here. Because, aggregate demand is driven by productivity, but it's also driven by the market power, which is going to capture what these elasticities are here. Okay, so it's going to depend on the distribution of productivities, and it's going to depend on the market structure. There's a typo here, my apologies. Okay, so given that, just one thing that I want to drive home here is that even though there's general equilibrium effects, there's going to be aggregate wages that are going to in fact, be determined by the distribution of AH and AL. But at the firm level, notice that the price elasticity has disappeared here. There is no price elasticity. That is, the price elasticity, the market power in the goods market, okay, does not, at the firm level, affect the wage ratio. And the reason is because, well, the firm that sells its good, okay, and uses a low-skilled and a high-skilled worker to produce the good, okay, still faces the same demand. And therefore, the demand elasticity relative for high to low-skilled inputs cancels out. I mean, this is fairly straightforward. But the economic implication is that there is no direct effect of market power on the wage ratio. There is a general equilibrium effect, and I'm going to come to that later. So general equilibrium effect, levels of wages throughout the economy can be affected, okay? But there is no direct effect at the firm level, okay, of the price elasticity. Good. So when we aggregate, this is just a few kind of details of how we aggregate it, but I just want to say when I'm going to talk later about, you know, I'm taking an average AH. Notice this, again, we observe an individual firm level AH, but I may want to make statements about aggregate AH or aggregate AL. I'm just going to do this and weigh this by employment. It could be different ways. If you know, we can, if you have a preferred way, we can repeat all these exercises also for different weights. The same thing we're going to do with the markdowns. For example, I'm going to have a mark down for each firm. I'm going to weigh that by employment. Now, if I were to try and get closer to the Katz-Murphy setup, what would Katz-Murphy tell me? Katz-Murphy would say, you know, the aggregate wage, the average wage of the high types relative to that of the low types, in this setup would be given by what? Well, the Katz-Murphy equation, right? The elasticity of substitution weight here, the ratio of average AH and AL productivities, and again, the ratio of H over L employment in the economy. We have one more thing that Katz-Murphy does not have. We have rent share and we have monopsony. So it's also the average markdown of the low-skill type workers over the average markdown of the high-skill type workers. Remember again, it looks inverse because this was on the left-hand side. So the markdown was multiplied by WH and the markdown for the low types was multiplied by WL. So by writing it on the right-hand side, I basically get the inverse of that. So in other words, my wage equation is exactly like Katz-Murphy, but of course, all the heterogeneity and market power is in this term. And I'm going to show you towards the end that this term is huge, indicating that this heterogeneity and this market power accounts for a large share. Given the setup that we have, what I want to do now is just tell you, look, let's see and solve this model as we change the number of firms that compete. Okay, I'm going to start with 30 firms here, and I let the number of firms that compete go to 2 or 1 if you want. Okay, notice that when I have a decreasing scale, the reason why is because going from left to right is basically going from competition to market power. Okay, so the more I move to the right, the lower the n is, the more market power I have. What is the effect on kappa? Kappa here is notation for the skill premium, the wage, the average wage of the high types over the average wage of the low type. What we see is that the kappa is increasing. As I have more market power, I have a skill premium that goes from 2.3 up to 3 here. Okay. And the idea is that this is going to be driven by the general equilibrium effects, and second, by the relative effect of the labor supply elasticities. Now, it's not just the effect on the skill premium that matters, it's also the effect on the wage level. Okay? If you look at the wage level for both the high and the low skill types, what we see is these are annual wages. What we see is that the wage level substantially decreases. In fact, it nearly halves if I go from 30 firms to 2 firms, say. Okay. What is this telling us? It's telling us that, firms that have market power, okay, basically produce fewer units. Then by producing fewer units, what this implies is that the demand for labor goes down. Why? Because by producing fewer units, I need fewer inputs. This is a general equilibrium model. There's labor supply. Whatever the labor supply is, the labor supply is going to adjust. Okay? But in order for there to be equilibrium with a lower labor demand, we're going to have lower wages. And this is what this is reflecting. And notice that this is mainly driven, this decline in the wages, by the output market power, not so much by the input market power. This is all driven by the input market power. This is driven by the output market power when we decompose those. Notice that this is true so much for the high-skilled workers as it is for the low-skilled workers. The equilibrium wage for everyone is declining, okay, as market power goes up. Now, what do we know about the three other kind of prices? They're not really prices, but kind of key measures, which is one, the markups, the price over the marginal cost. Not surprisingly, as the number of firms decreases, the markup increases. Okay, what happens to the markdown? Well, as the number of firms decreases, the number of competitors decreases. What happens is that the markdown goes up. Okay, the spread, or the wedge rather, between the wage and the productivity is becoming bigger, both for the low type and the high type. So in summary, what we see is that as in this model, as we change the number of firms that compete, we see an increase in the skill premium, we see a decline of all wages. Okay, and the decline of wages is substantial. And at the same time, why is this happening? Well, because prices are going up relative to marginal cost, and the wages, the markdowns for the low and the high types workers are going up too. Why is that? Because remember, labor supply is upward sloping. As the labor demand goes down, we move down the labor supply function, and so we're going to have lower and lower wages, and that's why we see this this increase in the markdown, the increase in the gap between productivity and wages. Now, we can do the same type of comparative statics. I have several, and let me just pick one. Let me basically pick, for example, the variance. Why is the variance of productivity? By the way, if I use small letters A, that means the log of A, so I vary here the log of AH. What happens? Well, the markup goes up. What's going on here when I increase the variance of AH? Well, if I increase the variance of productivity, think that this is a Cournot market. Let me start maybe with the markup here. What happens to the markup? Well, I have, starting from identical firms, I now go to firms that are more and more unequal. What this means is that as I have, a higher productivity firm competing with a low productivity firm, even if this would be a mean preserving spread, what's going on is that the high productivity firm is actually capturing a larger market share, and basically its weight in the average markup is going to be higher, and that gives rise to a rising markup. The same thing with markdowns. Okay, as firms become more unequal, markdowns go up too. The level of wages is going up because there's also the issue that, at least for the high-skilled workers here, there's more extreme productivity, high productive workers, and this has a positive productivity effect. It appears that the low-skilled wages, the wages of the low-skilled workers go up too, but notice that this is a very small change, and whatever this increase is coming from the fact that labor is complementary. So the low-skilled workers basically benefit from the increase in the productivity of the high-skilled workers. You can easily see that you would expect that the skill premium is rising, not surprisingly, because more is being produced by the more productive firms. As I said, I can do this for different settings where the variance changes. I mentioned earlier the elasticity of substitution has very small effects on both wages and on the skill premium, and this is a change in one of the parameters. If sorry, I just look. I see another question here from Renata. I'm just wondering why high wages do not go down more relative to productivity like we observe in the standard monopsony model. I think you probably refer to the case of, let me go back to that, I presume you refer to the, actually, yes, you refer to this case. So basically, why do the wages of the high types do not go down more, I guess, relative to the low types? Well, that's a good question. That's going to depend on the relative elasticities that we estimate. Okay, we have monopsony in both low and high skill type workers. Okay, and I can kind of preempt you. What we see is that for the estimations that we have now, is that actually the monopsony power, surprisingly or counterintuitively, of the high type workers is actually higher than for the low type workers. Okay, so it depends, of course, the effect of N is therefore bigger for the high type workers than for the low type workers, but it could be the other way around. And for this simulation, I believe that we use the same elasticities for the high and the low types. Okay, just the level differs. But I'm going to show you when we estimate this what quantitatively the effect is on both the high, on the high type versus the low type, and they could definitely be different, but it's going to depend on what the elasticity of the labor supply is of each of them. Okay, so if there's no more questions, what I would like to do is just give you an idea of how we take this to the data, and the quantitative exercise is going to consist in basically backing out two things. The first thing that we want to back out is the productivity, and this is meaning basically a joint distribution of high and low productivities per firm. Okay, each firm is going to have its productivity bundle of high and low types of workers, and we're going to back out also the market structure. That is the number of firms that are competing for it to be consistent with this the observed revenue distribution. So how do we do it? We use US data. We basically merge LBD and the sense of manufacturing data to obtain revenue with the LEHD, which has data on education, employment, and earnings. Okay. For those of you who've worked with this data, they're not ideal. In fact, I think the Brazilian data is actually quite a bit more complete. Here we have to impute education for a subset of workers. We have to extrapolate for missing years because the census is only every 5 years. And you'll see that what we're at the moment doing is we can estimate this on the macro data, but we, in order to solve the model, we basically simulate data from the macro data and then work with these simulated data, which gives us a very close substitute to using the real data just for a matter of computational attractability. So what do we observe in the data? We observe basically the employment level at each firm by skill. So I see the number of low type workers and the number of high type workers. I see the wages by skill. So I see at the firm level, we see the wage bill, the payroll by low skill and high skill workers. So basically I see, if I know how many workers there are, what the average wage per worker in the skill class is. And third, we see revenue. So we see basically the sales of the firm. And with this data, we're going to be able to back out the productivity of the firm and the market structure. And how do we do that? Well, first of all, the big challenge is the unobserved market structure. And as I mentioned earlier, there's many other things that pollute, if you want, the measurements using HHI. So when we use concentration indices, the problem is that we basically, we cannot kind of define exactly what a market is. So what we're going to do instead is we're going to take an approach where we estimate the market structure a little bit as a residual, a little bit in the kind of the fashion of a solar residual for TFP. What is a solar residual? Well, you say, I don't know what TFP is, but let me tell you, I see what firms produce, I see the inputs that they use, and I see prices. So basically, once I see labor and capital, okay, and I see basically what they're producing in terms of revenue, well, the residual must be TFP, and that's basically what Solo does. Now, Solo does this in the aggregate. You can do this for distribution of firms. What we're going to do is we're going to assume, as I showed you in the model, we assume a particular structure. Okay, with market power. And so what we're saying is, by relaxing the competitive nature of these markets, we basically have one other component, which is the number of firms that are competing. Because if I see the inputs, okay, I can tell you basically what the elasticities of the labor supply are, what the TFPs are, but by linking this to the revenue of the firm, I can actually tell you how many firms must be competing with each other. The fewer the firms, the more market power, the higher your revenue. And so the revenue is going to be a measure, if you want, of how much market power there is given inputs. And so our N, the number of firms that are competing, is going to be basically be identified off the revenue of the firms. Now, we also don't know what the market structure is. And so the way we do it is we construct very narrow industry geographical sectors. We put all the firms from that same NAICS code geographical area into one bin. And then sometimes, depending on this could be a few number of firms, it could be a few hundred. And then we randomly sample firms to compete with each other. Now, this is crazy from a micro viewpoint because, why would you randomly sample? The only thing why we do this is because we cannot know who competes with whom within a metropolitan area in a given sector. So, all the coffee shops in Sao Paulo, I know that they somehow compete, but I don't know who competes with who. And you might say, well, but in the case of a coffee shop, I should take a smaller area because, one part of town doesn't compete with the other part of town. The point is, by randomly sampling, we take kind of this solo residual type of approach, and we say we're agnostic about who competes against whom, but if there is fiercer competition, the revenues will be lower for a given set of inputs, okay? And this is going to basically be in the model consistent with a higher number of firms competing. Instead, if I see higher revenues, it must be fewer firms that are competing, okay? And so even though we're agnostic about what a market definition or what a market is defined as, we use information on the type of sectors and geographical codes, and basically we use the random assignment as a way to say, okay, I don't know who competes with whom, but in the aggregate, okay, to be consistent with the type of revenues that we see, I must have had so many firms competing compared to what I would see with other revenue. So let me just tell you what the estimation procedure looks like. There's basically 3 steps. The first thing is we're going to try and obtain the common elasticities for the labor supply function. Okay, so think of this eta hat L and eta hat H as being the slope, if you want, of the labor supply function. What is the data that I use as an input? Well, I have the firm level expenditure or wage, sorry, of the high type workers and the low type workers. Okay. Now, why does that allow us to obtain from this the elasticity? Well, it turns out that in our model, the wage equation, okay, basically only depends on aggregates and these elasticities. And so if I see a sample of firms, okay, and I see basically their employment levels, because that's what I have the data. By the way, I don't even need it, but if I see the sample of firms and I see their wages, that's what I meant to say. Okay, we can basically estimate these elasticities. How do we do it? We just look at the minimum distance criterion at the firm level. Okay. What's the identification argument? Well, that the variance of the wages in the models are monotonically increasing in eta hat. Okay, and that's the same thing for eta L. So there's a monotonicity of this eta hat in terms of the variance. And so wages that are going to have more, markets that have more variance are going to have to be corresponding to a higher eta H. Second, once we have the wages, we can look at the firm-specific technology and try to back that out. So this is the AH INJ and the AL INJ. Now, remember we're within Cournot here, or Bertrand, and that means we have a number of firms, N firms competing. These N firms have 2 first-order conditions. They have the first-order condition with respect to H and respect to L. So if they were to know AH and AL, they would solve for H and L, okay, across these N firms. By the way, there's many of these markets, but because there's no strategic interaction, across markets, you take what happens in the other markets as given. Then you ask the question, okay, I do not see the AH and AL, but I see H and L. So basically, we're going to solve backwards the system of equations. Rather than solving for L and H, I'm going to solve for AH and AL given H and L. Okay. Computationally, this is somewhat intense, but it's a fairly straightforward problem to solve. I solve this in each market. I guess what these aggregate prices are, and I basically solve market by market until I converge. And then the last step is to use the data on revenue to estimate the market structure. And what is this going to achieve is that I'm trying to understand, or I'm trying to measure what the number of firms is that is needed for getting a revenue distribution that's consistent with what I see in the data. So the model gives me a particular revenue distribution, okay? And what is the identification argument here? The variance of the model revenue is also monotonically decreasing in n, okay? And so as this variance changes, I can basically obtain an identification of what the number of firms is. What's my objective? Just I want the revenue in the model to match the revenue in the data. I'm going to use a minimum distance criteria. Okay, these are some parameters. As I said earlier, we're using the elasticities in the goods market from Eeckhout Bernstein. The elasticity of substitution is SMO, Blue, and Alter. And for now, we're also using the elasticity between markets from a paper by Berger, Herkenhoff, and Monge. We have some more results where we estimate them themselves, and they're actually very close to the ones that we had obtained here. So what's the procedure in estimating the wage elasticities? So basically, what is the slope of the labor supply function? Well, the theory tells us, as I hinted at earlier, the wage of a particular firm can be written as a function of aggregates. This is the aggregate wage. This is, remember, this index, CES index of the aggregate wage. This is the total employment. And this is the employment in your market, and this is your own employment. Okay, so basically, if I observe this, okay, I basically can back out what the wage is. Or alternatively, if I have the wage, I could back out this. But the fact is, we observe both. We see the wage and employment. So what we're going to do is we're going to say, look, for all these firms, I see wages and employment. Let us estimate these elasticities that make this relation in the data, okay, satisfy this relation in the model. And when we do that, what we find is that the elasticity for the high types doesn't change much and is low. So the within labor market elasticity for the high types is 1.85. It doesn't change. For the low types, it's high and it drops from 10.13 to 6.11. What do we conclude from this? The first thing we conclude from this is that the elasticity of substitution in the high type market is actually quite low. So these labor inputs are not very good substitutes. It's fairly costless. There's a lot of friction for high type workers to switch jobs. Instead, for low type workers, this elasticity is very high. And it says that for them, it's easy to switch jobs, although that has gone down a little bit over time. Notice that the difference between high and low type workers is consistent with the result of a recent paper by Goolsby and Severson, who look at the academic market, and they find that people, who are higher up on the pecking order, people on tenure tracks and with tenure, they estimate their labor supply elasticities using a different approach. They basically look at an instrumental variables approach to estimate this, and they get low elasticities for the high type workers and high elasticities for the low type workers as well. The implied distribution of the skill premium at the firm level. Okay, so what we have is basically we see the data and the model, and the first thing that you can see is that the model and the data is going to look fairly similar. We have a similar evolution. We have a shift to the right. Not surprisingly, by the way, this is in logs. Okay, this is the log of the wage ratio, because we know that there's an increase in the skill premium. So we expect this to see, at least on average, at all firms. It may seem that the variance has gone down, but this is in logs. So remember that the variance in levels has gone up of this distribution. The first step, as I said, was to derive what the labor supply elasticities were from the wages. The second step is to estimate these technologies. Remember, we observe labor inputs, high and low type labor inputs, and what we want to know is what are the productivities, what are the AH and AL at the firm level. I said we solve for this system of equations, okay, computationally intensive but not undoable. What is the inputs in this procedure? Well, first of all, take a look at what the ratio of log H over L is. Okay, so basically H minus L in logs. What is this? Well, when we go from 97 to 2012, we see that the H over L ratio moves to the right. Okay. Well, first of all, it's moving to the right for the reason that we would expect, because the supply of high-skilled workers has gone up and the supply of low-skilled workers has gone down. So you would expect that there's a rightward shift of the entire distribution, so that on average, H over L could be higher. But again, this is a log normal distribution. This is basically its approach it looks like a log normal distribution. The variance in the level distribution is actually going up substantially. It's going up by a factor nearly 3, okay, from 0.35 to 0.97. And this is the type of evidence that people have found about this increase in between firm inequality. Why? Because the H to L ratio says how different firms are from each other. Go to a world in, say, the 50s where all firms had, 10 high-skilled workers and 50 low-skilled workers. They were all factories, and all firms looked like the same. You would have a mass point, right? H over L would be 10 over 50. Now, if you have an increase in heterogeneity, you're going to have more firms that are full of coders and no low-skilled workers. So the H over L ratio is going to be very large. Or you're going to have a lot of cleaning firms, okay? No H's, a lot of L's. This H over L ratio is going to be very small, okay? The log of it is going to be very negative. And so the variance, the fact that this variance has nearly tripled, is a sign that this between firm inequality has gone up. Okay, that's what's basically driving this. Now that's the input that we use for kind of this estimation. What is the output? The output is that we estimate the technology, which is basically the AL and AH distributions. Okay, so what does this depend on? This depends on the data, what we see in terms of this H and L for each firm, but it also depends on the market structure. Okay, and this is what I'm plotting here is what the technology distribution is for what I'm later going to estimate as the equilibrium market structure. I'm going to come back to that later. And what do we see? We see that basically the AL distribution has shifted to the right. Remember, I talked about technological regress not being the case. So the low type workers are becoming more productive. Also, they do. The high type workers, as we expected, are becoming more productive. Sorry, this is going too fast. So what is this is also telling us is that basically the low type workers, their productivity has gone up, even if their wages has gone down. There must be another reason why their wages has gone down. This is the ratio of technologies, if you want, the equivalent of the H to L ratio distribution across firms. Okay, because what is this telling us? It's telling us that the AH over AL distribution has shifted to the right. So this is already indicating that the Katz-Murphy story is important, because that's telling us, yes, there is skill-biased technological change. It's moving to the right. Okay. Moreover, there's an increase in this variance also here in levels. The variance goes from 768 to 10,000. Okay, that's by a factor of more than 10. Again, this is telling us that this between firm the increase in between firm heterogeneity is driven by an increase in between firm technological change. Okay, so this is consistent with Katz and Murphy, but one step further, the results of Bloom, Govinnen, Song, Price, and von Wachter that have found that there's basically this increase in between firm variance. And we find that this is driven by technological change. Okay, so technological change is an important determinant here also in explaining the kind of outcomes that we see in this estimation. Now, the last part is, what is the market structure? How many firms are competing? What we estimate is that this value goes from, the estimated value for N goes from 16 to 4 between 97 and 2012. So as I said, this is based on the identification argument that the variance of revenue, okay, changes as the number of firms decreases, and we match basically the model revenue with the data revenue. The result of this are a number of markups and markdowns, of which there's the distribution, and you can see, consistent with what we have independently measured as markups, the spread of markups has gone up, and also the mean. And the same thing is also true with markdowns for high and low types. Let me just, to use the last 5 minutes of my time, think about the counterfactual exercise. What I'm going to do is I'm going to do a decomposition of the economy and say, look, I have estimated this economy. I know what the properties are in terms of productivity. I know what the properties are in terms of market structure. And let me just pretend that I go from 97 to 2012, okay, where I keep the 97 parameters, and then I'm going to change one thing, one parameter for a 2012 value. So for example, here, this is 234 is the skill premium in the model of, the data. When I have the 97 number of firms, which is 16, let me change the number of firms to 4. What happens to the skill ratio? It goes from 234 to 255. What is my objective? My objective is to get from 234 to 271, which is the skill premium that I observed in 2012. Okay. So my objective is to move from here to here and ask how much in each step can I explain. Of course, when I'm in 2012 and I've changed all the parameters, I'm going to have explained 100%. So this counterfactual exercise is kind of, what would in 1997 have been the skill premium if I had less competition? It would have been 57% of what it is now. Okay, the change. It would have been 255. What is the effect on welfare? Not so big. I mean, there's this kind of 2.5% decline in output and nearly no decline in welfare. But there's a substantial decline in wages. And this is something that I mentioned before. The general equilibrium effect of market power on wages is large and substantial. Okay, so what we see is that when we go from 16 to 4 firms in each market, wages for the high skilled types go down by 9%, percentage point. The wages of the low skilled types go down by 17%. Okay, of course, this is what's driving this increase in the skill premium ratio. Now, let's look at this one. This is skill bias technological change in some form. It's more than skill bias technological change, because what I'm going to do is I'm going to change the TFP distributions. So I started with a 97 TFP distribution with a 97 N number of firms with the 97 parameters that I've estimated. And I'm going to say, let me now have all firms have TFP given by the 2012 distribution. What happens to the skill premium? The skill premium goes up. So this is partly explaining skill bias technological change by 35%. Now, the key thing of technological change is that, as you saw in these derived distributions, technologies shift to the right. We see output go up by 43% and welfare go up by 43%. So there's a huge increase in productivity. That's what the TFP is telling us. It's skill biased to some extent because it's affecting to the high skilled more than the low skilled. Okay, and wages go up by 30% for the high skilled, 23% by the low skilled. So that difference is explaining the rise in the skill premium. Then we do different combinations of everything. When we get back to the final outcome, what do we see? This is saying, I take the 2012 number of firms, which means that there's only 4 instead of 16. This is this estimated elasticity from 2016, and this is the productivity distribution from 2012. This is the productivity distribution from 2012. We know from the data that we should explain 100% of the skill premium, which is 2.71. But let's take a look at what happens to output, welfare, and wages. First thing we see is that output goes up by 5%. You say, oh, that's good. Well, it's not really good, because if we had had the circumstances of 97, but the same productivity would have gone up by 43%. We know that productivity has increased a lot, okay? But we see very little of this in output, and we see also very little of this in welfare. Instead of a 43% increase in welfare, which we are due to expect from the increase in productivity, we only see 8%. Why? Because there's fewer competitors, and because this elasticity has changed. So basically, the productivity gains are kind of eaten away by the inefficiency that we see from the rise in market power. And this 30% wage premium is actually now a wage loss of 4% for the high skill type. And the 23% wage premium for the low type is now a wage loss of 17%. The bottom line is that you have opposing forces. You have an increase in productivity, which raises output and welfare. It does so somewhat disproportionately more so for the high types than for the low types, but many of these gains are offset once market power is taken into account. Okay? What market power does is it basically shaves off all these gains in productivity and leaves us with less welfare and output, and also with a bigger difference between the high and low type wages. I'm running out of time, so what I'm going to do is I'm going to kind of just tell you what the issue here is. We do the same thing, but rather than going from 97 to 2012, we do the opposite. Okay, we can do the same type exercise. And let me just conclude. Market power, I think, is driven by both technology and market structure. Okay, and we know from Katz and Murphy that skill-biased technological change plays a huge role, and we confirm that here. But there's also a role for the market structure, and in particular, the fact that market structure, has an effect both on the skill premium, okay, and the size of the effect is quite sizable, the effect on the skill premium, and we see a large welfare loss. Okay, the wage inequality that results is basically very inefficient. And so when we think about policy, we should think not about policy just to, obtain redistribution. We should think about policy in which we reduce market power and concentration in order to actually gain efficiency. I think to us, a surprising result that we keep on finding is that there's a large general equilibrium effect on the wage level. Even if there's not a big effect on the skill premium, the effect is still 50+%, but the huge effect is on the wage level. Okay? And now, I talked at the beginning about the issue of wage stagnation. You do not need technological regress to explain this decline in low skill wages. The reason is because when we have, even in this case, increased productivity of the low skilled workers, their wages go down because of market power leads to more extraction of the rents by the firms. And finally, we also find that there's market monopsony power that's actually larger for the high types than for the low types, in the sense that the substitutability of high-skilled work, even within the same market, is less than substitutability of low-skilled work. It's easier for a barista to move from one coffee shop to another and work for the other one than it is for maybe someone in management from one firm to move to the other. And then let me just finish with two fundamental insights that I take away from this, which are not necessarily exactly about the contribution of market power, but they are about kind of thinking about market power in the macroeconomic setting. The first thing is that we really cannot use a representative firm framework. And the reason why is because all of these results that I obtained come from the heterogeneity of productivities. If I had had a representative firm, okay, all of these effects would disappear. You can even see the Katz and Murphy equation in front of you. There's basically no general equilibrium effects. The second thing that I take away from this is that we can actually estimate market structure as a residual. it's a very crude way of doing it because we just randomly assign firms, but still it is like a solar residual for TFP that allows us to back out what is the market structure, okay, that is consistent with the type of revenues that we find. And then finally, I think, you know, when we see the type of results we obtain here, when we think about the economic impact of market power, there's an effect on efficiency and there's an effect on inequality, but these two are not disconnected, okay? We have many reasons if we see rise in inequality to maybe advocate for policies that do redistribution. What I'm trying to point out here is that if you have a rise in market power, policy that addresses the efficiency or the lack of efficiency, okay, will also have an effect of reducing inequality. And these things are closely interconnected. And I think we cannot just completely ignore this connection and treat them separately. This is all I have for the talk. I'd be happy to take any questions that you have.
Thank you, Jan. Thank you very much for the great talk. Our time is up, but I think we can have maybe one question. Anyone? No questions? Okay, so I'd like to thank you, Jan, again, and we're gonna end this section. Thank you, Jan. Thank you very much.
Thank you everyone for joining.
Thank you. Bye-bye.